So this is just a very basic Spotlight dashboard. And the main thing I wanted to show you guys is I've got just one CA in this environment. And if you drill into the CA, you go here, you go into the CA itself, configuration, you can see over here on the left-hand side, we have access control list that there's been some hardening done to the CA. Tier 0 certificate managers, we actually are participating in the ESAE system here. And we've really delegated authority to on the CA. We've done some hardening. We've gone through a hardening exercise, and this is important for later. I'm going to move to a client now. So this is our client, and on this client, we're going to try to run some PowerShell. So we have to add a PowerShell. It's just test.ps1. I'll show you what it looks like when we get done. But this is what we're going to try to do. And you notice that it didn't work. It's not digitally signed. You can't run the script. So, okay, well, let's do the regular bypass. The regular bypass would be set execution policy. And we'll just go unrestricted. Sure, that's a great idea. Oh, and we can't do it. There's something that's causing us not to be able to do that, to set that execution policy. So, if we go and we look at that file, you can see that it's just doing effectively a ping, right? There's nothing else there. It's very, very basic, and we're blocking that. Now, pretend as you will that this was malicious code. Now, a bad guy came in, we'd be blocking this, and this would be a protection mechanism that would block this code. Okay, we need to have it signed. So let's see what happens when we actually sign that file. So we're going to swap windows here to this guy, and I've already got it queued up to where we will sign that file, and then there was a signature there. We'll go ahead and clear our screen here to make it a lot easier for viewing. We're going to notepad that file again. And you can see now that there's a big giant signature block sitting right at the end of the file. The file has changed. So do we expect it to run? Yay, nay? Let's see. It says, do you want to run this software from this untrusted publisher? So you can see here, we've got the certificate stores, and we don't have anything in trusted publishers in that certificate store. Let's pretend, for instance, that I just, I'm a quick, irresponsible administrator, and I'm going to go ahead and just hit A. So yeah, we're always going to run it. And we'd run our ping, and everything runs, right? What exactly happens when you hit A there? Well, if you go into that certificate store and you refresh, you can see that there is now a code signing certificate in there. It's sitting in trusted publishers for the current user. It's say we have a certificate in there, and that's the signer. So now we can run that code. So if the malicious code was signed, it would actually be able to run as long as it's in trusted publishers. And there's a couple of issues with that. So first and foremost being that how easy was that to accidentally leave that certificate in that store for that user? It was just a very simple slip. If you were running in the PowerShell IDE, you would actually get a pop-up box, and you'd be able to click on it, and that option is on the far right, and it would be very easy just to click on it and add it in. The other thing there's a lot of different ways that you can add. There's a lot of different ways that can be laid down. One of which is it can be laid down via policy. So I'm gonna go ahead and refresh that real quick. in my not so subtle hidden window here that's refreshing group policy. And if we hit refresh here, on the trusted publishers, we now have code signing certificate in there. In fact, not only do we have one in there, we've got one in the local computer store as well, because it was assigned via group policy, right? We now trust this, this issuer all across the enterprise. So anybody that can modify group policy can enable this issue. And that, doesn't necessarily mean that you're enterprise admin or domain admin. There are a lot of ways to elevate to be able to apply group policy, change group policy without actually being, in those tier 0 groups. So you've really kind of reduced the profile of what somebody malicious could do. And then, there's the other fact is that you can actually hide this quite a bit. And when I say hide this, these certificate stores, so trusted publishers, if you go and you look at the certificate store view, and you go to view and then options, you can actually show the physical stores. And then we go back to trusted publishers. And you can see there's actually 3 different stores that are listed and enumerated here. You have registry, group policy, and local computer, right? And local computer is just kind of enumerating down from here. Group policy would be coming in if there was local user group policy, and then registry would be if we had this thing in the local registry, right? So that means if we used a script to lay down our REG file, we could get in there. If we used a policy to lay down a registry setting and a group policy object where there's a lot of registry settings being set, we can also have an issue there. A startup script, logon script that has an insertion point, we also can have an issue there. So there's several different ways that you can lay these things down to where they would be problematic. Here's the biggest kicker, though, is also in this folder with test.ps1 is we've got a file called invoke kimimets. And if we were to open that file up, well, look at that. That looks a little familiar to those of us in the community. And I've made a couple of changes to be able to get it onto the system. But the simple fact is this thing should have gotten caught by antivirus. It should have gotten caught by anti-malware. But what happened is we, at the very end, added a signature. And that signature, if we go to the file system, where that document, so you go where it's at, you look at properties there, digital signatures, and look at there. We're now sitting in trusted publishers, right? Because it's the reasonably legit code signing certificate that we have there. If we go and we were to clear that block, that signature block, and just save, I use arrows because my mouse is acting up a bit. I opted for a very large signature, and this is the side effect of it, is that you have a very large block to clear. You delete that signature block, and then you save. And then if you look in here, you have a file here. It's sitting there. So let's try to. In fact, let's go ahead and see if we can sign that file. Yes, we can. So it's very easy to go through, sign that, add that thing in there. And, it's not wrong. But without the signature, if you go to Windows Defender, you can see that it was quite an excursion to get that on there without a signature. And I can show you settings. Here we go. We look at the protections, privacy and security. It's let's see here, where was it? Protection history, there we go. So you can see, initially, Defender caught this thing. We had to, go through, adjust some things. If it would have came in signed, we would have bypassed all this. Now, I wanted to make sure that I was considerate of the environment that I'm in. It's a server that I'm not there. I got permission to add this. I got permission to do all this. You can see, where this potentially is bad, right? And then if you go a step further, it gets even worse when you consider that, there are a lot of suites that will completely overlook a file if the signature is valid and it's sitting in trusted publishers, right? So, if we go through, we scrub that. I imagine once we scrub it, we go file save, and thread would run. I imagine it would go away. And we actually can go through and check that in a second, because it takes a couple of seconds, but eventually I would expect I would expect the malware catcher to catch it. Right? It won't let us do if it's signed, so that's good. We go through, we add a signature. Eventually, we would, we'd be able to get on there. In a little bit, I imagine this is going to catch this though. So, what does that mean for us? And so if you go and you look, so this is a full view of like what Spotlight looks like. You can see, this is a lab environment, but specific to the environment that we're talking about, this one server, you can see that there's a couple of things that aren't necessarily kosher. Number one, there's a certificate template that's snapped in called bad code signing. There are events that we can see. You can see, there was hardening that was done here. You can see when the hardening was done. But if you scroll down before the hardening, you can see, if you go all the way down, you go into some events, you can see, there was some bad stuff that happened. A certificate template, bad code signing was added in Active Directory. A certificate template, bad code signing was added to CA for issuance. And we would go through, we would let you guys know, hey, there's this bad stuff that's happening. In the newer versions of Spotlight, there are other things that we would potentially trigger when that happened. We would have probably a best practices alert set up for that. So let's go into the best practice sources. It takes for a second to load, and there would be an alert, a best practice alert here. If it was something that was identified as a threat, our new threat portal would actually catch it. Right now, our threat portal in our next release is going to be covering the Petit Podum threat, but in future releases, we'll be looking at very specific threat profiles. So there's a lot of different things that Spotlight can do to help in these situations. So you might ask, what caused this to be an issue? So I think there's a couple of different things that we can deduce from the CA itself. So I'm bringing the CA in. And so you can see right now, okay, in the certificate templates, we do have the bad code saying that's a problem. If we actually look at the certificate template, we go right-click Manage. You can see that before the hardening was done, bad code signing. If you look at the security, You see, oh, authenticate users, they have read, that's fine, we can read it. But then you can see that the username Sean has read and write on this template. Even more concerning, domain admins and enterprise admins have the default permissions of enroll. But the most important thing is that the user that made the duplication named Sean, that's currently not a member of any groups that are allowed to do anything from an enterprise perspective, has right on the template. So that means they can adjust certain settings on the template. If you look at on advanced, they're also the owner. So when you duplicate a certificate template, the person that duplicates it is listed as the owner, and they also have right permission. So if this exercise happened 5-10 years ago, before we implemented the hardening for the ESAE or for the tiering model, this user that's been the permissions have been perceivedly taken away. Those permissions are sitting in an ACE just buried somewhere. So that's one issue, right? Potentially. There's another potential issue. If you go to, and this one's probably the more common issue. If you go to so suppose we did like a network scan and we're looking for a very specific file type. That file type would be a PFX. So if we will go and we look at that, oh, look, we've got a PFX, certificate import wizard. Oh, what's this? We have current user. Where do we want to put it? I don't know. We'll just put it local. And then we got password. Let's go ahead and guess what the password is, right? That was easy. And looky there, if we go to the trusted root certification authorities, or not trusted root, current user, now we've got that code signing cert, and we've got the private key. So what causes us to be in this situation, right? A, putting it on the net logon share, that would be bad. B, let's just say the developers, they put on a share in Teams or they send in an email or something like that. I mean, it's one of those things that a lot of dev shops, they'll do that. If they need to have a key for signing, they're just going to spread it around. It's a trivial exercise to sign something. You don't necessarily want that to circulate. You want maybe to circulate a test certificate, but not necessarily the one that you're using for your enterprise application. Ideally, you'll have those things stored, in an online vault, like an Azure Key Vault or like an online HSM or on a local HSM instead of in the local stores. And, you don't want that stuff floating around in email or on a share or something like that. So why is this important? If you look at the news in the last few weeks and then just in general, there's a lot of threat actors that are using this factor. Most recently there was a Windows hardware compatibility certificate that was used to sign a malicious driver. In the past, there were other code signing certificates that were used, and if you sign code and it's signed by a legitimate certificate, or even worse, if it's signed by an EV, an extended validation certificate, it has the ability to bypass almost every single control you have out there, whether it's a group policy control, a software restriction control, application whitelisting, anti-malware, threat detection software, you name it. If there's a legitimate signature on it, we're going to let it run. If you go a step further, oh, this is the Windows only problem, right? You know, you can still jailbreak other systems and put bad code in there, right? You can jailbreak iOS, you can jailbreak Android, you can insert, legitimate but bad certificates, sign stuff, get it running, and go on. You might even be able to fool the vendors into thinking that those things are legitimate.